Okay, time for the long-awaited, much promised and seriously delayed integration by parts. So this is something which in the last couple of lessons I've just put a big arrow and said parts, because it's a technique which enables us to deal with what looks like products. So here's an example where we appear to have, well, just a product with two things multiplied together, but we don't have the product rule as such for integration. We use this technique called integration by parts, and here's what you'll see on your formula sheet. And so if we're trying to integrate something which has two bits to it, we can use this formula. So here's our two bits. One of them we're going to call U, and the other we're going to call V dash. And then we work out the other bits, the U's and the V's and the U dashes, work out all the bits, and stick them into this formula here. And the big trick is, because these aren't symmetrical, one's the U and the other's a dash, it does matter which one is which. So when we do the basic product rule, we used to have UV, and it doesn't really matter which is which. Here it does matter which is which. And the priority order for choosing U is if something's got a log, make that U. If there's no logs, then just a basic power. And if there's no basic powers, then exponential power will be your choice for U. Okay, so looking at this example, here's our two bits. One of them has got a log, so this bit we're going to call U, and this bit we're going to call V dash. And the way that I always do these things, you don't have to do this, but it works really well for me, is given that we want to find all the various components, I just make a wee table with U and V, and that's the normal function, and that's the dash. So I know U is log x, and V dash is x squared. Okay, so then I have to differentiate here to get from normal U to U dash. So if I differentiate log x, I get 1 over x. And going this way I have to integrate, because this is V dash, and I want to get back to V. So it's going to give me 1/3 of x cubed. And now I've got the four components that I want. So this integration should be U times V. So that one times that one. So log x times 1/3 x cubed minus the integral of U dash V. So that one times that one. So 1 over x times 1/3 x cubed. Okay, which is, what have I got? Well, it's just no integration, that's already done. So I've got 1/3 x cubed log x minus the integral here. That x can go with one of those x's, so that gives me 1/3 x squared dx. So if I integrate that whole thing, I get 1/3 x cubed log x minus 1/3 of 1/3 x cubed plus c. I can take 1/3 x cubed out the front. This is just tidying things up a little bit. And I'm left with log x minus 1/3 plus c. Okay, and that's the integral of that. So if you differentiate this thing, you'd get back to that. Okay, and that's what we mean by integration by parts. So key things are determining which bit is U and which bit is V dash, and the order does matter. And then for me, just working out the four components is a really good way to do it. And then it's very easy to stick them into the formula, and away you go. Okay, so that's really all there is to integration by parts.